using the TServerSocket component. This letter was originally posted to Delphi 3000.com. The Delphi documentation on the TServerSocket's multithreading capabilities can appear a little sparse for the untrained eye. I will try and shed a little more light on the subject. Actually, it's pretty easy to make a multi-threaded server that listens for messages on a socket. Delphi has a component for that, the TServerSocket. But you need a little bit of knowledge to use it. In order to structure your work, you should add a TServerSocket to your main form. Set the Servertype property to stThreadBlocking. Create a new unit, shown below, containing the server thread. Make the following code on the OnSocketGetThread procedure TfrmMain.fSocketGetThread. Sender, TObject, ClientSocket, TServerClientWinSocket, var SocketThread, TServerClientThread, begin // This creates the TServerThread object I have shown // in the code below. A new object is created each time // a new connection is established. SocketThread equals TServerThread.create, false, ClientSocket, and the TServerThread is an object I have created myself. The object inherits from TServerClientThread and contains the code that actually are reading and writing from the socket. The unit I created contains at least the following code. Unit server thread. Interface uses Windows, SCTComp, SYSUtils, classes, forms, type TServerThread equals class, exception, // the server thread is a descendant of the // TServerClientThread. TServerThread equals class, TServerClientThread, private fSocket stream, TWinSocket stream, public procedure client execute, override, // the client execute overrides the // TServerClientThread.client execute / and contains the actual code that is / executed when the thread is started. End. Implementation procedure TServerThread.client execute. Begin inherited free on terminate equals true. Try fSocket stream equals TWinSocket stream.create. ClientSocket 100,000 / 100,000 is the timeout in milliseconds. Try while not terminated and ClientSocket.connected. Do try // this is where you will do the actual / waiting for input, reading, and writing // the examples below shows what you can / put in here. Except on exception do begin / an error has occurred, close, and exit ClientSocket.close, terminate, and and, finally fSocketStream.free, and, except on exception do begin / an error has occurred, close, and exit ClientSocket.close, terminate, and, when the connection is established, the thread needs to wait for incoming data. You can use this code to wait for data, if not terminated, and not fSocketStream.waitForData, 1,000,000, then begin / handle the timeout end, / there are incoming data on the socket. To read data, you should have a buffer to store the data in. Usually the buffer is a p-byte array or an array of chars. In this example I have a buffer called fRequest which is an array of chars. Furthermore, I am expecting a fixed number of bytes. My array has the size of the constant request size. var AC, readln, integer, begin fill char, fRequest, request size, 0, AC equals 0, repeat readln equals fSocketStream.read, fRequest AC, 1024, / I read in chunks of 1024 bytes until the buffer / is full. AC equals AC plus readln, until readln equals 0, or AC equals request size, and if readln is 0 then I do not receive any more data. The read function times out after 100,000 milliseconds as stated in the TWinSocketStream.create. If you do not know how much data to expect, you should set this timeout fairly small. 30 seconds should be a maximum in most situations. When sending a reply, you should be aware of your client's behavior. Many clients only waits for one package of reply, others expects many packages. In this example, I have a client that only expects one package, so I have to send my data back in one chunk, fSocketStream.WriteBuffer, frep, freply size. The frep is the reply buffer, and freply size is the size of the reply buffer.